In this video, we will prove the formula for Sn for arithmetic series. On the board, I've written Sn in expanded form. So you can see the terms here, and they're added together up to the nth term. And underneath we have the formula, which is given in the booklet, but you need to know the proof of it. To begin the proof, we'll start by writing the expanded formula for Sn. So you can see I've got the first three terms here, and then I've got an ellipsis to show that the terms keep going on all the way up to the second to last term, and then our last term, our nth term over here. Okay, second line, we're going to rewrite Sn, but back to front. And when you do this, try and line the terms up underneath the terms here. This is what I mean. So I'll start with my last term, and I'll try and squeeze it in underneath the A. There we go. Okay, second to last term here. Third to last term here. Okay, let's put brackets around these. Alright, and then second term and then first term. Let's make that a little bit clearer. Okay, so I've written Sn twice, once normally, once back to front. Third line, we're going to add these two together. Sn plus Sn just gives us 2Sn. Now on the right, rather than writing one giant sum where we have all of the top terms added together plus all of the bottom terms, we'll pair them off. And we're going to pair them off with the terms that are on top of each other. So I'm going to add just these two, the first term and the last term, together, and write the sum just down here underneath. So we've got A plus n minus 1d. That's 2A plus n minus 1d. And now I'm going to add the second term to the second to last term. Okay, so A plus D plus A plus n minus 2d. Well, if you add those together, again, there are two A's. And then to count the D's, I've got n minus 2d's plus another D. That makes n minus 1d's. If you're unsure of that, you can just quickly work it out on the side. Right? So the 2a's add to 2a, I think that's clear. And then we did n minus 2d plus d. If you expand brackets, we get that. Collect the d's together. And then if you factorise the d out, you get n minus 1d. So that's what we've got there. Okay. Alright, third term plus third to last term. Add them together. Again, there are two a's. And then n minus 3d plus 2d's. If you're unsure, work it out on the side, but the answer is n minus 1d. Okay, and we keep going, and we do the last few. We kind of already know the answer to this anyway, because we've already done it. A plus d plus a plus n minus 2d is 2a plus n minus 1d plus 2a plus n minus 1d. Alright, and you don't have to be the most observant student to recognise all of the terms are the same. All the pairs add up to 2a plus n minus 1d. Almost there. We now need a way to simplify this sum. The question is, how many of these terms are there? There's n. If you think about it, there were n terms in the initial sum that we wrote. Again, there was n terms on line 2. So when we paired them off, we're going to have n terms on line 3. So line 3 can be simplified to this. There are n of these, n times 2a plus n minus 1d. And then finally, it's quite easy to make Sn the subject, we just divide by 2. And then just let the examiner know that you finished your proof. You can just draw a small square, or some people write QED, something like that. And the proof is finished.